again to our next video in the series of system design concepts. So in this video, we continue with our layered architecture and look at how we can scale the layered architecture. So let's first start with a quick recap. So this is the layered architecture that we had seen, where the request starts from the client, goes to the load balancer, from where it is distributed across the different layers. So we have the first layer is the front cache, where if the data is not found, it will go to the application server, and if the application server does not find the data within the cache or the MQ servers, then it goes to the web services. And we had another layer which is our CDN. So these were the layers that we saw. So now let's move ahead with the study. So for that, we divide our layers into two parts. One is the processing layers and the other is the data layers. So in the processing layers, we have the application server, the web services and the MQ server. So basically the part which handles the processing, and the data part, as we can see, are the cache servers and the CDN. So first we will see how we can scale these data layers, and then in our next videos we'll move ahead to the processing layers. So let's think about what the scalability of a layer is. So this scalability of a layer we can think of in the terms as the ability to add more instance clones to the layer. So for example, we had our application server layer where we had n instances. So what does it mean that for an instance to be clonable? So let's look at that. So for an instance to be clonable, it has to be stateless. So only when it is stateless, we will be able to clone it, and that means that whenever a requirement is like as we saw in our previous video, if we have a festival sale, then we can automatically add more instances. So for adding more instances to a layer, like automatically, it has to be clonable, and to be clonable, it has to be stateless. Now, what exactly do we mean by stateless? So, stateless means that the instance does not hold any state. And what a state is, or what state means, is any data that is locally held only by that instance. That is, the instance is holding some data which cannot be accessed by other other instances. So in that case, you cannot automatically clone the instances. So if we have to represent this pictorially, then this is how it would look like. So we have three servers, S1, S2 and S3. We have three users which these servers would be processing. So that is U1, U2, U3, and the data related to each user is D1, D2, D3. So now if we say that the server S1 will store the data D1 related to the user U1, what it means is that server S2 cannot process the data, it cannot process the further request from the user U1. Similarly, S1 cannot process user U2. So every user is kind of stuck with one particular server only. So definitely you cannot scale this architecture. So how can we resolve this? So we can move the data to a shared storage. So now every server will access the shared storage for the data. So any server can access any user's data. And so now we can easily map any user to any of the servers. So this is how we can, this is how, a method like where we can manage the state. So what exactly a shared storage is and how we can move the data, that will be looking in the next slides. So first, what we have seen till now is that we can move the data locally held by an instance to a shared storage. But what exactly do we mean by this data? What is this data? So there are four types of data that generally we will encounter as a part of any application. One is the session data for a user, that is the data that is related to the user, that is a part of every session with which the user interacts. Then we have local files, either files generated by your application or uploaded by the user. We have local memory state, that is the computations which your application will hold, and the resource logs. So these are the four types of data that we need to handle. So we'll be going through each of these four data types, and we'll see how we can scale each of this type of data. So first, let us see how the session data can be stored so that it is made scalable. So, with respect to session, right? So we know that HTTP protocol is a stateless protocol. That is, it cannot identify the difference between multiple requests coming from the same user. So it will not see those as a same user request. It has no data to identify that. So what we do in this case is that we have the concept of a session to override this. So what this session does is it helps the server to recognize like with an identifier that the requests that are coming are from the same user or whether they are from a different user. So how can we handle the session data? So there are three ways to store the session data. The first one is cookies. So in this case, the browser needs to include all the session data as a part of every request. So what limitations it will place is that this session data, as you need to include it in every request, the session data has to be minimal and you need to take care of the encryption of this data. So these are the two limitations. The other option that you have is that of dedicated session storage. So what we do here is that we have an external data store. You will save your session data to the external data store uh, with the use of a session identifier, and the session identifier will be there in every request. So when you respond back, again you will store this data back to the data store. So this is how you can move your session storage to an external data store. And there are many options that we have over here. We have applications like Memcached, we have Redis, then Amazon provides DynamoDB, and we have Apache Cassandra. So you can use any of these options to create a dedicated session storage. So this is one option. Then we have another option, that is a third option, and that is of sticky sessions. So this is done with the help of the load balancer. So as we saw, a client initiates the request, it goes to the load balancer, and we have the server instances, that is S1, S2, S3, and these are what we are trying to scale. So how can we now maintain the session data so that our request can go to any of these servers? We do not have to like keep one particular server dedicated to one user. So how do we do that using sticky sessions is that the load balancer will first inspect the request header to check whether it has a session cookie. And suppose now the request is a new request, so it won't have a session cookie. In that case, the load balancer will assign the client to a web server, and the server will issue a cookie which is sent back to the client. Now suppose this user sends another request, or say you have another request which is a request which was already like sent, so there is some session data here. So in that case, what the load balancer will do is it will find the session cookie in the request header, so it will redirect the client to the web server that issued the cookie. So now in this case, suppose it was S2 which had issued the session cookie, so the load balancer will redirect to the server S2. So this is how we can use sticky sessions with the help of the load balancer to manage the session state. We have seen how we can store our session data so that we can make the layers scalable. So now let us go ahead and look at how we can store the local files. So the local file storage, if we consider, there are two types, that is the upload and the download. So upload basically is the user generated content that the user would like to upload to your web server. And the downloads are basically the files that your application generates and it wants the user to download them. So the way you can handle the downloads is you can generate the files and provide the URL to the user for download. This is one option. And in this case, you store the URL and the file location mapping in the database. And the other option is that instead of storing the generated file and the location mappings, you can on the fly generate the content and you can allow the user to download that file. So these are the two types of file storage. Now let's see what are the options we have for storing these kind of files. So one option is your own infrastructure. In this case, you have your file server within your own organization infrastructure, and that can be done with the help of RAID disk, that is a redundant array of independent disks. So you can use RAID disk to store the files within your application. But this is complex in terms of maintaining the scalability. The other option then you have is of cloud storage. So here you have options like Amazon S3 storage, or you have Azure Blob storage, which provides you with private and public buckets. That is, you can distinguish between private and public content. We'll see that in our next slide when we revisit the access controls. The other option you have is that of a CDN. So that is provided by a content delivery network provider. And the type of data that you can store in your CDN is always the public files. So whatever is private, you would not use the CDN as a storage for that. So that brings us to our access options. That is, how can we distinguish the uh, content into public and private, and what options do we have for each type of the content. So if we check for public content, we have files like images or posts, which can be made public. They are not something where we need to restrict the access. So if these files are public, we can use the CDN to deliver these files. So the CDN is actually an externally maintained network. Like you can use like Amazon options, and in that case, the what happens is like your request, the client first hits the CDN instead of hitting your web server if the content is available in the CDN. So this will considerably reduce the load uh, on your application server, that is your website hosting servers. And another thing you can do is you can specify a long expiration policy. So what it will mean is that like the data will be cached forever. So like suppose if you set a expiration policy of 1 week, after that the data will then again have to be fetched through your web application server. It won't be available in your CDN. So that is the option that you have for a public content that you want to make available forever. Now the other content is your private content. So how this goes through is your client sends a request to the application server. The application server will check the user permissions, whether the user is allowed to access that data. If not, if not, it will just send back an access denied like message or a response. And suppose if it is approved that the user has the permissions, then the application server will download the data from the shared storage. And the shared storage that we saw in our previous slide is either your cloud storage or your own infrastructure. And from that storage, the file that the server gets, it will send it back to the client. So these are your different types of content and how you have the access options. So with this, we have seen also how we can handle the local files using your infrastructure, the cloud storage, or you can use the CDN based on what type of a data it is and what are the access constraints for that data. So in our next videos, we will cover the other two types, that is the local memory state and the resource